Right, welcome everybody. This is we have a clock. This is Conrad Bagler. He will be talking about I2P DNS, a distributed network without central authority. 5 more seconds, you can start.
Thank you very much for having me. Do you hear me back there? Yes. Lovely. All right. Okay. I'm Conrad, and I have the opposite of problems, and I have a million of problems compared to Jaron. Because Jaron had performance issues, that was the thing before, and he tried to parse DNS zone files really fast. In the I2P network, which is an overlay network which provides anonymity, we have that few hosts. We don't even need to think about performance. We have, as I said, 1 million other problems. Now, the students of the University of Applied Science got the job from me to take a look at this DNS problem because the I2P network has no DNS. So, welcome to Stone Age. Right, a few words about DIVA.EXCHANGE, where I'm working for. We're a non-profit association based in Switzerland. So bonjour, grüezi. And we don't take any fundings, we don't take any donations because we want to stay completely independent. And I'm one of the independent researchers there, and software developers and architects. So we're looking at the concept of the I2P network, why I2P needs a DNS, where it is today, and what are its problems. Then I'd like to jump into democratic Byzantine fault tolerance quickly and give you an overview. This is not very much a technical talk, so it's rather a bit an overview talk. And then I hope to jump pretty quick off the 15 minutes, and I'm that grateful and thankful for the clock there, already into questions, because I can learn that much from you as experienced DNS people. And as I said, we're in Stone Age. Right, what's the I2P network? First question, who got in touch with I2P in here? Yes, not nobody. No, really, thank you very much for some I2P people here. It's an overlay network. So you have the generic internet infrastructure, and on top there is software. These are routers, and they create two things. They create confidentiality and total anonymity. Although at the University of Applied Science and other universities in Switzerland, we try to break this anonymity because that is a bit our research approach. But up to now, we couldn't break it. So until now, I have to say that I2P is confidential and anonymous. So we don't trust no one. I have my own node, and I only trust myself. And as you can imagine, in the world of DNS, hello, problems. By the way, before you misunderstand here something, I2P is a pure transport layer. It has no storage capabilities. So whatever evil things you might hear from so-called overlay network, and some people even call it darknet, no, it has no storage capabilities. It's a transport layer. That's what it is. Right. So, within an overlay network like I2P, we have public keys. Public key is a long string. Now, as also with some other networks like Tor, we try to shorten down these public keys by using hashing algorithms into a bit shorter strings. But A, U, O, Q, I, B, etc., is still nothing to be usable by human people, by people like you and me. It simply doesn't work. So DIVA.I2P, which is a valid service within the overlay network I2P, you would have to remember this one here. And that's simply not doable. And that's why we have, well, that's one of the simple reasons for DNS, short human rememberable names, which then are resolved to public keys. That's the basic idea. And that was the only thing we'd like to solve at the University of Applied Science. So a very, very trivial use case. Let's take a public key and let's map it to a nice name like FOSDEM.I2P, something like that. So something simple. As I said, we don't trust no one within I2P. There is nothing like a trusted source. We're just a peer-to-peer network transporting messages within this peer-to-peer network. And nevertheless, if I'd like to reach a specific service, let's take FOSDEM.I2P to read the schedule there. I need to have some kind of a resolver which tells me, you want this public key from the peer-to-peer network. So your messages must travel there, send a request, and then a response is coming back through a different tunnel in the I2P network. And ta-da, I have the schedule of I2P in front of me. But we don't have that, because there is nothing like a trusted source within the I2P network. There are so-called registry service, reg.I2P, but I don't know these people. Nobody knows them. It's an anonymous network. So why should we trust them? And like that was the reason why the students at the University of Applied Science in Lucerne, Switzerland, got from me as a lecturer the challenge, hey, come on, try to solve it. Give me at least some idea how we could do that. And one of the distributed technologies we have today available are, now, evil word, blockchain. No, it's a distributed layer. So we have several peers in the network. They all store data, very short packages of data, and we could store DNS lookups, also public keys and nice names, we could store it in this blockchain. And as long as this blockchain, and I know there are other projects around, I don't care, and as long as this blockchain has no token and no coin involved, it's just a distributed storage layer. Not more, not less. It's just technology. And for me, that's a bit the point where I'm looking at it. For me, it's just, I can trustless store data in the network. And that's what DIVA.EXCHANGE is about. And that's just one solution. It's not the only one. And I'd like to motivate. I'm a full open source developer. I do nothing else than HEPL3 and stuff. That's my job. But I hope other people use this democratic Byzantine fault tolerance to create other distributed storage layers. Right. Now, the students took this blockchain, they set it up, and ta-da, they had an API available locally on their computer to program a program to store key values. So a key, which is a name, and a value, which is a public key. That was the whole simple idea. And then the only problem of this blockchain was to properly guarantee that this key value, so the nice name, FOSDEM.I2P, and its very unreadable long public key, gets properly stored on this chain. And that was this democratic Byzantine fault tolerance. Byzantine fault tolerance is about 20 years old, and the idea is that as long as you have more than one working node in a peer-to-peer network than the faulty ones. So faulty is F plus 1, which are perfectly working in a network. You can trust it. Now, I don't want to bore you with the algorithms because I don't understand them. No, because you can read them up, and it's quite a long story, but believe me, the mathematicians, they have proof that this works well. So, and it works without tokens, and it works without coins. So trusting this democratic Byzantine fault tolerance is one possibility to solve this distributed storage challenge. I'd like to motivate you, if you find some time, to install, using DIVA Dockerized, this local environment. There is no cloud service or no central authority involved. And then you can run this program. There's a README, so you can run this shell script, and then you have a container environment available on your local machine, which is giving you I2P network access, which is giving you blockchain access, and then you can program, or you can simply use the HTTP API to store data in this fully distributed network. So that's the whole magic about it. It's not really complicated. This is in detail for further readings. Thank you very much for the time sign. Perfect. You can follow these instructions, and if you have questions, don't hesitate to ask in our channels, because also the students were struggling. So that's kind of normal. But once you're into it, you'll figure out that you have your local node with I2P running, and with the blockchain running, as said, no coins, no tokens involved. I already talked about that. Just one thing more. There's a so-called binary Byzantine fault tolerance consensus, or a binary problem. So every node in the network decides between 0 and 1, and every node in the peer-to-peer network decides. So that's one of the conditions within this democratic Byzantine fault tolerant using the binary consensus. But when we have something like a key value thing we want to store, so FOSDEM.I2P and a public long key, then we have a so-called set problem, because every peer in the network might have a different opinion about this key value. And that makes it a bit more complicated, and there have been books written about it, and you'll find these books at the end of this presentation. There are the sources given, so if you'd like to read into the details, but it's solved these days. And the last 2 years have been important for the development on the research of this stuff. Okay, then there were the specs, and then after the specs, they produced solutions. The students produced solutions in several languages. You'll find the solutions on GitHub. So you can already look at their solutions. Obviously, as I said, it's very trivial. We're in Stone Age, so it's really, really trivial. But it works. And if you look at testnet.diva.exchange, which is obviously ClearNet, or not the overlay network I2P, you can see all the records which the students have produced. And then there are some demo entries. And as soon as you try this out at home, you can create records on this blockchain and visualize it on a ClearNet site. Right. By the way, to isolate the key values, we have simply used a namespace concept. Also, this is absolutely not acceptable in a productive environment. But in a research environment, it was totally okay. All right. So if you're looking then at the blockchain, you see some JSON data. And in there, you see the data which represents this key value. So an I2P address, like from container 221.I2P, this is the name, and the B32 hash. Obviously, it would be more elegant by storing the full public key. It would be easier for the I2P network to parse that. Let's already move on to the summary and takeout, because I have 12 minutes left, and I'd like to spend them on questions and your input, or your critics. So the summary and the takeout. For us, in a peer-to-peer network, where we don't have performance problems because the network is that small, we believe that the binary Byzantine fault-tolerant blockchain is one solution, a valid solution to the given problem. Additionally, we face a million problems, especially in the context of DNS, spamming, squatting, I guess you call it. So there are lots of problems related to having a DNS within I2P. So please also understand that the current implementation is just a prototype, and if somebody or somebody of your students or somebody you know would like to participate, yes, we're here to help, and we're happy to help because it's a fully open source project. Here are the sources for further reading, and there is GitHub, and there is also a book which came out by a Swiss researcher which is currently working in Sydney and teaching there, and he has a lot of good ideas about the scalability of Byzantine fault-tolerant blockchains. Right, that's it, and therefore my last slide, and I have 10 minutes left, and I'd like to use them for questions. By the way, you can also go back in the slides if you're interested in something else. Okay, please.
How would I claim a name, an existing name, legitimately and illegitimately? So either if the person that currently owns it doesn't want me to have it, or would like to sell it, for example, or hand it over.
The question was... What was the question?
If it's already registered, how would I be able to register for another B32 address?
Right, the question was how to register properly and claim a name and link it to a public key or to a B32 hash. He's pointing, he has the finger on the problem. And correct me, DNS people, if I'm wrong. Isn't this called squatting? Like trying to take over some of... No, okay. Hijacking. Thank you very much. Hijacking. It's the hijacking problem. And this is totally unsolved in an overlay network like I2P. Personally, but that's just my personal opinion as a researcher, the decision mechanism of the Byzantine fault-tolerant blockchain, the decision mechanism solves this hijacking problem. But it means nothing else than the majority, let's call it 50% plus 1 for the simplicity of the argument, that the majority of the node operators believes that this is right. So Coca-Cola.I2P is then linked to this public key because 50% plus 1 believes that this is right. But obviously hijacking, I mean, nobody can control whether this is really Coca-Cola which claims that. So yes, you have the finger on the problem, and yes, that's one of our big problems. Answered?
Yeah, it's answered.
He said yes.
Additionally, would it be possible legitimately? So if I agree with that person, that it's okay?
The question was whether it's legitimately, but...
With the existing owner of the name.
All right. Can we discuss this afterwards, please? Thank you very much, because I'd like to. Please.
Are there constraints on the number of nodes in the network? Because if you're doing a consensus algorithm and there's an unbound number of potential people involved in the consensus, then hijacking becomes even bigger problem because you can modify the consensus.
The question was, is there a limit of scalability of the blockchain, right?
Well, yeah, more like, because it's consensus-based, if there's a bad actor who can just register a limited number of nodes and influence the consensus on his own.
Okay, the question is a bit more complex than just it's a scalability question. So, first question, let me quickly answer the scalability issue. Scalability within blockchains is a huge topic. The researcher which I pointed out the book, and I really can recommend this book here, the Democratic Fault-Tolerant Blockchain, and its scalability. Please take a look at this book. There he talks a lot about scalability. He believes that's a good thing. So it works. But to answer your other question, which was, well, does bad actors influence and might make hijacking even easier? My view on it is that once we have democratic Byzantine fault-tolerant properly in place, including decisions, it's simply the majority. And if the majority agrees that this public key equals to Coca-Cola, then it must be true. Yeah, obviously for DNS people, this is a very weird thought. Please.
Question from the chat by Ed. How would the reuse of a name compound these issues? Have you thought about this challenge? So reusing names is the question. How would it work?
Right. Do I need to repeat this question?
Yes.
Okay, so how does reusing work? Can we prevent reusing? Fact is, once it's a decision on the blockchain, it can't be reused. Well, that's the current setup on how it's programmed. I saw a question there. Yes, please.
Yes, this is kind of similar to this question over here. Is really a question about Sybil resistance. Is about whether or not a single person could create a majority by themselves.
No, a single. His question.
A bunch of nodes on their own.
Right. So what you're talking about, the question was, can a single person create a majority on its own? In a blockchain, this is known as majority attack. So yes, if you run all the nodes, and the other people on the network are too lazy to create more nodes themselves, yes, as soon as you own faulty +1 nodes in the democratic Byzantine fault tolerant, yes, you're the boss. That's a fact. But that's a fact that's true in every distributed system. That's not a blockchain problem. That's a distributed system problem, very much at its lowest level. So yes, you're absolutely right. Own the world, and yes, you say what's going on. Please.
Well, so Bitcoin solves this problem with proof of work. So there are solutions. But just the point I was going to make on a question.
So your question is whether proof of work is a solution to a problem.
Right, so the problem that this guy brought up is Sybil attacking the network. The reason why Sybil attacks are possible is because starting a node does not cost any resources. And so you can just make a lot of nodes, right? And you can just make 1,000 or 10,000 or whatever. Because it costs nothing to make a new node, you can make as many as you want.
Right.
Whereas with proof of work, you have to expend a certain amount of energy.
Right. Okay, the question was, is it within democratic Byzantine fault tolerance totally free to start a node? And is proof of work one solution to this cost problem? I studied economics, and yes, in theory, you're right. Proof of work is a solution to a problem, creating a lot of other problems. So today in blockchain research, we think about other things, and we don't think that starting up democratic Byzantine fault-tolerant node is totally free of charge, because you need to work for your stake first. So if you don't let your node run for a longer while and create through good behavior positive stake, you will never ever get assigned to have a vote in this network. That's the proof of stake modified approach which is valid today. Please.
If someone else has a name, registered name, and they forget, they lose their private key, is that name forever lost to everyone then?
The question is, if somebody loses his private key which registered a name, is this name forever lost and occupied in the current implementation? Short answer, yes. Don't lose your private key.
For everyone?
You're absolutely right. He re-asked for everyone, and the answer is yes for everyone in the current implementation. Yet another problem ticked on my list.
One more question back there.
One more question. You're the last one, please.
If I want to register a domain name, can I register as many as I want? Is it free? How is that currently implemented?
Okay. The question is, can I register as many DNS? Can I register as many names as possible, and is it free? The answer is A, you're in a peer-to-peer network, so you're using your own resources. I don't care. There is nothing like a central business model. Nobody will ever send you a bill. So it's your own computer, it's your own peer-to-peer, it's your own peer, it's your own effort. You write it on the chain, you pay the bills, not my problem. So yes, it's free forever. And we can't create any business model because it's peer-to-peer. It's not possible. And since you're using your very own resources, you can create however much DNS records you like, as long as you get the majority on the blockchain. So thank you very much.
We have one more question.
Whoa.
55 seconds.
55.
Yeah, my question
there was the question whether there is the possibility to, was this a CNAME question or something?
Something like that, or like that, for example, or what DNS mechanism
Okay, so the question is whether we already support advanced DNS topics within our prototype. The answer is no, we support nothing at all. We support a name and the public key, and time is up, so thank you very much.